Buckle up, folks. For decades, we thought that brain size directly dictated intelligence. But Einstein's tiny titan of a brain was actually smaller than average, weighing only 2.6 pounds. And here's the kicker, the record holder for the largest brain ever measured, a person with developmental delays. The human brain is still shrouded in mystery, and it continues to amaze us with its secrets. Now, let's dive into some real-life experiments. 8 scientists and 1 chef volunteered for an epic adventure to Antarctica's Neuroplasticity station, where they spent 14 long months exposed to extreme cold and isolation. These brave individuals are about to give us a fascinating glimpse into the boundaries of human resilience. Imagine being cooped up with 7 others in a tiny research station for almost a year and a half. No personal space, no social breaks, and 0 connection to the outside world. That's what our brave scientists experienced at Antarctica's Neuroplasticity station, an environment eerily similar to what future long-duration space travelers might face. As physiologist Alexander Stahn from Charité Universität Smedis in Berlin puts it, it's breathtakingly beautiful at first, but then it gets monotonous. Now, he's teaming up with Professor Simon Kuhn of the Max Planck Institute for Human Development to uncover how this extreme isolation impacted our participants' brains. Let's get ready to find out. You might have heard that isolation can mess with our brain's memory GPS. The hippocampus and lab rats agree. When these furry friends are surrounded by buddies or toys, they learn faster than when left alone in a bear cage. But would humans follow the same rule? Our team of scientists wanted to find out. Before some extra researchers joined them later on, our Antarctic adventurers were all alone during the harsh polar winter, with temperatures plummeting to a bone-chilling 50 degrees Celsius, 58 Fahrenheit. No evacuations or deliveries could reach them. They were truly cut off from the world. To track their mental fitness, the team took computer-based tests before, during, and after their mission, focusing on skills like attention, memory, reaction speed, and spatial thinking. But that's not all. Our Antarctic explorers also underwent some serious blood tests to check their BDNF levels. You see, BDNF is like a brain superfood. It helps nerve cells grow and connect with each other in the most amazing way. The team even used MRI scans on 8 of these brave researchers to see how their brains changed during their isolation, focusing specifically on the hippocampus, where new neurons are born. Now, you might know that our control group, made up of 9 friends who didn't venture to the station, got to participate in identical tests. What they found was pretty shocking. The adventurers' brains had shrunk by an average 2% in a crucial part of the hippocampus called the dentate gyrus. This reduction directly linked with their performance on cognitive tests. Spatial awareness and selective attention skills took a hit, making it harder for them to focus and block out distractions. Now, you'd think that when we retake tests, our scores would go up, right? That's called the learning effect. But here's the thing, those who braved the isolation actually didn't see as much improvement in their test results as they should have, and this was linked to a dip in BDNF levels. So, what can we learn from all of this? Stan explains that our hippocampus is super sensitive to stressors like being alone for an extended time, but it's also extremely responsive to social interactions and exploring new environments. This gives us hope. These changes might not be permanent. But here's a twist, those Antarctic adventurers we were just talking about. Well, it turns out that even after they returned home and were no longer isolated, their BDNF levels didn't bounce back to normal. This has left researchers wondering if these changes can truly be reversed. Now, before we get too down in the dumps, there is some seriously cool science happening here. Scientists at Caltech found that 6 young adults who had half of their brains surgically removed as kids due to severe epilepsy.
Yeah, it's a heavy one.
Were still able to function pretty normally because the other half of their brain basically stepped up and took on those lost responsibilities. It just goes to show how amazing our brains can be at adapting when they need to. Now, let's not get too excited just yet. We're talking about a tiny group of people here, so more research is definitely needed to confirm these findings. Still, what they've discovered in these brave souls does line up with some initial rodent research, suggesting that pushing our bodies and minds to the extreme can indeed have a negative impact on our brains. The Caltech team wants to dig deeper and see if exercise might be a key to protecting against those changes. And speaking of pushing limits, a group from Kazakhstan embarked on their own Antarctic adventure, albeit for just 11 days. They aim to explore how our bodies and minds handle extreme conditions, but we'll have to wait and see what they discovered in the icy vastness. Let's dive into what happened during that Kazakhstan expedition. Measurements were taken every 3 days, so we've got data from those 4 points. The team members, who averaged 29 years old, were pretty pumped up on day 1. Excitement and curiosity took over. But as the days went by, the scenery started to feel repetitive and their interest dipped. However, that initial tension proved useful in getting them moving, helping their bodies adjust faster to Antarctica's chill. By day 4, they'd reached a peak of adaptation. Think of it like a aha moment. Their cardiovascular systems and mental state were working together smoothly, causing a temporary spike in blood pressure. After that high point, things gradually leveled out as they settled into expedition life. Now, let's see how things changed after that adaptation peak. As the crew settled into their routine, we noticed something cool. Their heart rates dropped dramatically and stayed steady for the rest of their trip. Their breathing also slowed down consistently. It was like they'd hit a rhythm in Antarctica. What's more, after day 4, their emotional state started to lift, getting close to those high levels from day 1 by the expedition's end. But here's an interesting thing. Despite being busy with chilly winds, long days, and just 2 meals a day, the team members' indicators actually balanced out by day 5. This was a delicate time for the group, as they needed to bond quickly since most of them were new to each other. Strangely enough, establishing that positive vibe turned out to be the toughest part. It wasn't until they reached the South Pole on the final day that their team dynamic really clicked into place. Let's talk about what might have happened if this expedition had gone on even longer. Their mental state could have taken a turn for the worse. Now, you might wonder, what exactly are we dealing with here? Well, being in harsh conditions like cold temperatures and feeling isolated can do some serious damage. Research on rodents showed us just how much of an impact it can have. They turned aggressive when exposed to constant stress. And if these little guys were left alone for over 2 weeks, they lost their ability to handle threats. That's a pretty big deal. But here's the really interesting part. Scientists found out that it all had to do with something called tachycanine peptides building up in their brains. When they blocked these peptides, voiled no negative effects of isolation on the rodents, mental health could be spotted. It just goes to show how complex and fascinating our minds are. So, what does this mean for us? Well, these experiment results could actually help in treating some mental illnesses. Who knew rodents would be such great test subjects? Now, let's talk about how our bodies handle being cold. It turns out we're pretty fierce warriors when it comes to keeping warm. When your body temperature drops between 95 and 89.6 Fahrenheit, things start getting intense. First, your blood vessels constrict so that they don't flow to your limbs, but instead focus on warming up the heart and brain. Talk about prioritizing. Next up, your hairs stand on end like little heat shields trying to trap warmth close to the body. Basically, nature's way of giving you a fur coat. Then comes the shivering madness. Muscles contract uncontrollably to warm you up from the inside out, making things really chilly for a bit. But here's the cool part. When it all stops, your blood vessels dilate and start sending warmth to your limbs, leaving you with this lovely feeling of heat. It's like nature's own thermostat is turning on. Let's talk about what happens when things get really, really cold. We're talking 86.9 to 85.1 Fahrenheit here. Your body temperature drops to a dangerous level, triggering a coma. Your heart stops beating. And worst of all, your brain starts starving for oxygen, leading to its eventual shutdown. But this slow-motion death can actually give doctors the time they need to save people who've been frozen. It's like science fiction come true. So, how would you handle extreme conditions changing your brain? The floor is yours. Share your thoughts in the comments below, and don't forget to hit that like button if you enjoyed this video. If you're new here, consider subscribing to my channel for more edgy content, and let's keep the conversation going. Before we wrap up, remember to spread the word about our channel letter. Share it with your friends who love learning like you do, and if you want more mind-blowing content like this, be sure to hit that